What would you think if I told you that warp propulsion is no longer pure science fiction? Can you imagine that we will soon have spaceships traveling at the speed of light or even faster? Scientists have even discovered a completely new way to travel 10 times faster than the speed of light. You'll be amazed at the fantastic changes this will bring in the future. Faster than sound, faster than light. Concorde, the supersonic passenger plane that took just 3.5 hours to fly from Paris to New York, was a milestone in aircraft development. Concorde has long been history. Today, only fighter jets fly at supersonic speeds. We humans have long since reached the next threshold on our way into space. We need spaceships that are faster than light. Otherwise, the enormous distances in the cosmos cannot be bridged, and we would need millennia just to reach the next star system. For a long time, physics did not seem to allow humans or anything else made of matter to travel as fast as light. What was the reason for that? Well, it's simple. Einstein stated in his equations of general and special relativity that nothing in space can travel faster than light. Matter can't travel even close to that speed because, in that case, equations of dynamics and energy requirements no longer apply. Scientists truly had to think hard to solve this puzzle. Now, there may be a way to bend time and space to our will and create a spaceship that can travel faster than light. If you love science fiction space movies, you already know the warp drive. In real life, the spaceship accelerates for a moment, then only a bright light can be seen, and matter disappears in time and space to reappear at any place in the cosmos. Enormous distances are covered in a very short time, and travel to the farthest reaches of the cosmos would be real. Although the concept was popularized as pure entertainment by authors such as John W. Campbell and legendary Enterprise creator Gene Roddenberry, science picked up on the concept in the 1990s, bypassing Einstein with a trick. Einstein's theory of special relativity states that energy and mass are interchangeable, and travel at the speed of light is impossible for material objects with a non-zero rest mass. This means that objects traveling at the speed of light require an infinite amount of kinetic energy to reach that speed. Theoretically, the dilemma can be solved by folding or warping space around the object, what means to distort or bend. Instead of creating thrust with energy, the force is invested in distorting the space. A kind of fold is created through which the spacecraft then slips with relatively little effort. Einstein's theories, which have become the scientific foundations of cosmology and physics, were unaffected by this concept. Two problems remained: generating the energy to fold space and technical feasibility. In 1994, Mexican physicist Miguel Alcubierre solved the problem, at least at the theoretical level. He used Einstein's theory of general relativity during his doctoral studies at the University of Wales to develop a framework within the limits of the laws of physics that would allow faster-than-light travel. On the practical side, relativity states that objects become heavier and heavier as they travel faster and faster. It's logical. The heavier these objects become, the more difficult it becomes to maintain acceleration or even increase it to the point where a spacecraft reaches the speed of light. Only particles that have virtually no mass can travel at these enormous speeds. Photons are among them. Miguel Alcubierre developed a drive, which was named after him. The principle is simple and easy to understand, even for laymen. A purely local expansion of the space-time continuum behind the spacecraft and a contraction in front of it allows motion that is perceived as faster than light by observers outside the distorted region. The occupants in the distortion, on the other hand, would perceive nothing, or let's say not much. Perhaps they would perceive the famous trail of light, see the stars whizzing by, or notice a slight vibration. Within a few moments, a warp spaceship could cover immense distances, truly as if in flight, or otherwise said, in faster-than-light flight. The Alcubierre Drive is virtually capable of expending an enormous amount of energy to contract and twist the space-time continuum in front of it, creating a bubble that simultaneously folds space. This bubble is a physical inertial system, which is why the occupants would not feel any actual acceleration. However, the rules of physics would be obeyed inside the bubble. Inside and outside, everything would conform, and nevertheless, matter could move in this way faster than light through space, not with thrust and speed as we know it from cars, airplanes, or space probes, but by an ingenious trick. The universe offers unknown possibilities. One mistake we humans like to make is to think of the universe as one space. According to relativity, however, space-time is a flat sheet that is distorted by any object with mass. The space effect, as we know it, comes from the influence of mass, and it is this distortion of the space-time continuum found at all corners of the universe that we experience as gravity. Yes, even you are distorting space-time a little bit right now as you are sitting there in front of your computer or smartphone, and you are causing gravity. In this context, of course, the exciting question arises: could a human being also push through a time fold by consciously contracting the space in front of him and come out somewhere else in space? Theoretically, this is possible. Practically, however, you would have to produce a whole quantity of force to distort the space by a multiple more than this happens only by your weight. The Alcubierre Drive creates the bubble necessary to evade the laws of physics outside and inside with a propellant. This is exactly where we still have a bit of a problem because, whether we use diesel, gasoline, hydrogen, or methane, we currently can't muster the power. In fact, we would need energy equivalent to the mass of Jupiter to muster the energy with means known so far. In the meantime, however, a solution has been found for this problem: negative matter. This exotic substance, which has a negative mass or energy density in theory, is supposed to be the long-sought answer. However, if we look a little more closely, we find that here again a tiny little problem appears. Negative matter is not only hard to imagine but also undiscovered so far. Its existence is suspected, but it is not proven. So, how to construct a drive with something that may not even exist? And even if we could detect this form of matter, the question is, how could we collect or create enough of it to power a spaceship? Where there's a problem, there's a solution. Researchers don't rest easy when it comes to warp drive because we need it. There's no question about it. Before we turn to the latest and most ingenious idea of a practically absolutely feasible warp drive, let's take another look at where we humans stand technically right now. Hold on tight because now it could become painful for all who dream of faster-than-light travel. Researchers have already found numerous indications of particles that neither assume a stable form nor are measurable in any way nor have mass. You would be to know how many such particles exist in the subatomic realm. It appears that these building blocks of matter are far more common than any fixed, determinable quantity. In terms of our reality, this suggests that our material world is not as solid, material, and predictable as we once thought. Albert Einstein, the great icon of astrophysics and mathematics, developed the famous theory of relativity around 100 years ago, which extended the basis of Newtonian physics. However, just as Newton could only describe part of nature and the cosmos in his era, Einstein also recognized only a part of it. Expanding these aspects of natural science is now unavoidable, as evidence that the old theories cannot be entirely correct is everywhere. The James Webb Space Telescope has shown us rows of discoveries that challenge old theories, and even the Hubble telescope has revealed galaxies so ancient that they defy our existing framework of physics. Calculations by past researchers have long revealed serious weaknesses in old models, particularly in explaining large-scale structures of the universe. Radio telescopes have discovered gigantic structures spanning galaxy clusters that do not align with Einstein's calculations. Furthermore, old approaches fail to explain the universe's nonlinear and accelerating expansion. Clues strongly indicate that answers to the universe's mysteries lie in the world of the smallest particles, such as baryons, tachyons, quarks, and others. In this realm, entirely different conditions prevail, challenging the predictability of previous physics. Particle physics breaks established principles, potentially even allowing backward time travel. For instance, researchers Samuel Kramer and Ian Redmount have found potential explanations for the universe's accelerated expansion in data from Type 1a supernovae. Their findings suggest that tachyons might explain the nature of dark matter, which comprises much of the universe but remains invisible and unmeasurable. Tachyons, with their superluminal speeds, could explain why dark matter is elusive yet influences gravity and the cosmos structure. While it remains unclear whether tachyons are building blocks of dark matter or merely exist within it, they may possess unique energetic properties capable of generating new forms of energy. This could enable faster-than-light travel, profound changes in quantum physics, and a better understanding of matter and time. If tachyons exist and transmit information faster than light, they could reverse causality, upending the traditional sequence of cause and effect. This would open possibilities for multidimensional causality and align with discoveries like a mysterious stream of neutrinos from Earth's interior, suggesting a hidden dimension where time runs backward. Tachyons could act as catalysts for dramatic changes in quantum fields, transitioning them to more stable states and revealing new phenomena. Despite challenges to Einstein's relativity, quantum field theory mathematically supports the existence of tachyons, underscoring their importance in physics. Tachyons could influence symmetry, a fundamental concept in physics, and play roles in breaking symmetry, uncovering new dimensions, and explaining particle masses. In the broader context of space exploration, innovations like warp drives and faster spacecraft could redefine humanity's cosmic future. Although current limitations prevent faster-than-light travel, ongoing advancements in particle physics and quantum mechanics may hold the key to overcoming these barriers and realizing interstellar travel possibilities. Great at first, but there is a catch. The light from the stars is very weak, and if you are close to the sun, our sun would intensify this effect. Your eyes wouldn't be able to see what little light there is, and the sunlight is so bright that it outshines the faint starlight. Scientists suspect that this effect would even occur when traveling between star systems. Again, it would be the vacuum of space that prevents the light from the stars from being scattered. Only when you get closer to the next star system and the particle density increases would you see light again. This is strange, isn't it? Because we know from movies and television depictions in which the universe is full of bright stars seen from spaceships. On your journey through space, however, you would encounter even more strange things that you certainly didn't expect. You are young, and everyone else has aged. You may think that time is the same all over the world, but that's not necessarily true. According to Einstein's special theory of relativity, time slows down when you move at a high speed. This means that if you take a long journey through space at high speed, Time will pass more slowly in your spaceship than for people on Earth.